The last thing I want you guys to understand how to do from this section is how to find the equation of a tangent line. And this is really the only thing that requires any actual computation. Everything else was conceptual. So let's say you have this nice simple function here. It's just a parabola. It's y equals x squared. Right? And let's say you wanted to find the equation of the tangent line that goes through this point right here. That's the point 3, 9. Okay? Well, we have a point. All we need now is a slope, right? Because we have point and slope, we have the equation of a straight line. So we need to find the slope of our tangent line. Now we know we can approximate it by looking at slopes of secant lines as they approach it from one side or the other, but the actual real rigorous way of finding it is pick a point, any point. Let's say this is my point right here, my point P. And if we look down here, right, we started here, this is 3, and point P has an x value that's right about there. And we'll just say that this distance here is a distance of A. Take the slope of the line that connects those two dots and then let the distance between them go to 0. So as it sits right now, our slope is change in y over change in x, right? Which is the whole y1 minus y2 over x1 minus x2 thing. Okay. Well, what are the coordinates for this? If this little distance is a, then we're now at 3 plus a. And then the height, yes, I know it's 11, but we want to keep it general, right? So the height is just going to be f of 3 plus a, right? Which in this case, since this is my f, it's really just going to be 3 plus a, comma, 3 plus a squared. And again, we can work this all out. And now we've got 3 plus a, comma, and then this is going to be 9 plus 6a plus a squared. Right? That's 3 plus a squared. Okay, so change in y, y1 minus y2. So let's let this be y1, and then therefore this has to be x1, and then the original, put in green, the original numbers are going to be the y2 and the x2. So let's work it out. We've got 9 plus 6a plus a squared minus the original, right, which is just 9 all over 3 plus a minus 3. So we can see that the 9's cancel, the 3's cancel, and you get 6a plus a squared all over a. Well, the top has an a in it in both pieces, so you can factor that out, right? 6 plus a, and those cancel, and so your slope ends up being 6 plus a, and then we're supposed to take the limit of this as a goes to 0, right? The idea is we're taking the limit as this distance goes to 0, so we're letting this arbitrary x march closer and closer to 3. So if we take the limit as a approaches 0 of 6 plus a, that's just simply 6. So we just found the slope at this point of 6. We have a point, So y minus y1 equals m times x minus x1. Remember that formula for point slope? So y minus 9 equals 6 times x minus 3. Y minus 9 equals 6x minus 18. And y equals 6x minus 9. There you have it, the slope of the tangent line that goes through that point. And I'm not going to draw it because I can't draw a straight line. But that's the equation of the tangent line at this point here. And that's everything you need to know for this section.